In this lesson, we will explore fundamental trigonometric identities and apply them to simplify expressions. Now, what is a trigonometric identity? Well, a trigonometric identity is an equation involving trigonometric ratios that is true for all values of the variable. Some trigonometric identities are a result of a definition, while others are derived from the relationships that exist amongst trigonometric ratios. What do we need to know? Some important trigonometric identities to remember are shown. And keeping in mind, it's your angle measure is always greater than or equal to 0 and less than or equal to 360 degrees. The reciprocal identities. So these are based on definitions. Sine theta is always equal to 1 over cosecant theta. Cosine theta is equal to 1 over secant theta. Tangent theta is always equal to 1 over cotangent theta. And we know those are the reciprocal identities. The quotient identities. Tan theta is always equal to sine theta over cosine theta. Cotangent theta is equal to cosine theta over sine theta. Notice restrictions are given because we know that the denominator can never equal to 0, and that's why those restrictions are provided. The other relationship identity derived from relationships is the Pythagorean identity, and that comes from the Pythagorean theorem. Sine squared theta plus cosine squared theta is always equal to 1. These other two Pythagorean identities we won't be using, but they do exist. So 1 plus tan squared theta is equal to secant squared theta, and 1 plus cotangent squared theta is equal to cosecant squared theta. To prove that a given trigonometric equation is an identity, both sides of the equation need to be shown to be equivalent. How do we do that? This can be done by, 1, simplifying the more complicated side until it is identical to the other side, or sometimes we have to manipulate both sides to get the same expression. We also want to rewrite all trigonometric ratios in terms of x, y, and r. It's very important to rewrite all expressions involving tangent, the reciprocal identities ratios in terms of sine and cosine. Often we have to apply the Pythagorean identity where appropriate. And of course, use the common denominator factoring as required. So the rule of thumb is you start with the more complicated side, and then you put all ratios in terms of sine and cosine. If you've done that, then we move further and see, is there a common denominator? Or is maybe we can factor in order to make sure to show that the left side of the equation is equal to the right side, that they are equivalent. Okay, so in example 1, we have show the identity is true using x, y, and r, and then we want to prove that tan theta is equal to sine theta over cos theta. So just a little bit reminder, we know sine theta is y over r, cosine theta is equal to x over r, and tan theta is equal to y over x. Okay, so if we look here, we're going to say the left side was equal to tan theta. We know tan theta is equal to y over x. And then we break it down to the right side. So we want to show sine theta. And because it's shown as a fraction, we know that's the same thing as divided by cosine theta. Now, sine theta we know is equal to y over r, and we're dividing that by cosine theta, which is x over r. Okay, so now we put that in terms of x, y, and r, but now we have to simplify. If we're dividing fractions, we keep the first fraction, we take the reciprocal of the second, and then we multiply. Okay, notice we can cross-reduce, so we can say these r's cancel out, and we're left with y over x. So therefore, we've just shown left side is equal to your right side by rewriting the ratios in terms of x, y, and r. Okay. Looking at B, we want to show that sine squared theta plus cosine squared theta is equal to 1. So we're kind of proving those quotient identities above and the Pythagorean identity in B. So sine squared, so we're going to say left side is equal to sine squared theta plus cosine squared theta. The right side is equal to 1. Now, of course, the right side is pretty simplified. We're going to work with the left side. Now, we know sine is equal to y over r, so this is going to be y over r all squared plus cosine, which is x over r all squared. So in this case, we know this is going to be y squared over r squared plus x squared over r squared. And we know that x squared plus y squared all over r squared. Now, if you remember using our knowledge of the ratios, we know the radius, which is equal to 1, right? Radius is equal squared is equal to x squared plus y squared. Well, if we have x squared plus y squared, that means we would simplify this to r squared over r squared, which is also equal to 1. So therefore, we know left side is equal to your right side. Let's move on. We have prove each identity. Again, we are looking to prove that the left side is equal to the right side. So we have tan theta is equal to tan squared theta times cotangent theta. Now again, starting with the left side is equal to tan theta. The right side of the equation is tan squared theta times cotangent theta. Now, it's important to express all the ratios in terms of sine and cosine. So we're going to start with the right side because it's more complicated, but using the quotient identities, we know tan squared theta is the same thing as sine squared theta over cosine squared theta. And we also know then that cotangent is cos theta over sine theta. Now, keeping in mind, we know there's two coses in the denominator, one in the numerator, so those cancel out. Those cancel out, and we are left with sine theta over cosine theta. So then looking at the left side, tan theta, we know according to our quotient identities that that would be sine theta over cosine theta. And we've shown that therefore left side is equal to your right side. Moving on, we have 1 plus cotangent squared theta is equal to cosecant squared theta. So again, breaking it down, we know left side is equal to 1 plus cotangent squared theta. The right side is equal to cosecant squared theta. Now the right side, that's pretty, that we know that's that reciprocal of 1 over sine squared theta. So, and then we're going to work with the left side. So 1 plus cotangent is cosine squared theta over sine squared theta. Again, using the quotient data. So in this case, now we've expressed everything in terms of sine and cos. Now we see that we have to take 1 plus. So it doesn't quite look like the right side, but we have to work towards making it look like the right side. So this is where we're going to look at adding fractions. So the common denominator here is sine squared theta, sine squared theta. So this would become sine squared theta Okay, so keeping the sine squared theta plus cosine squared theta all over sine squared theta. Well, we know, according to the Pythagorean identities, sine squared theta plus cosine squared theta is equal to 1. So we have 1 over sine squared theta. So we've just shown left side is equal to your right side. Okay, so again, the rule of thumb express everything in terms of sine and cos. Always start with the more difficult side first. If you've depleted that, so if you've expressed everything in terms of sine and cos, then you want to look like if is it common factor or if where you have to, because we're adding fractions, get that common denominator and simplify. Okay, looking at C, we have left side is equal to 1 minus cosine squared x. Right side is equal to sine of x times cos of x times tan of x. Okay, so tan, we want to express it in terms of sine and cos. So it'd be sine of x times cos of x times sine of x over cos of x. So in this case, again, we can simplify by reducing the cos and cos, and then they cancel each other out. And we're left with sine x times sine x, which is sine squared x. Now, we know using Pythagorean identities, if sine squared x plus cosine squared x is equal to 1, sine squared x would equal to 1 minus cosine squared x. So if we work on the left here, we can say that is equivalent to sine squared x. So therefore, the left side is equal to your right side. It's always important to break it down, always express all your terms in terms of, sine or cosine, and then either factor or expand or find a common denominator in order to make them equivalent. Okay, so left side we have cos of x. Right side is equal to 1 over cos x minus sine of x times tan of x. Left side, we don't do anything there. We're working on the right side. We have 1 over cos of x minus sine of x. We know tan is sine of x over cos of x. So simplifying would be 1 over cos of x minus sine squared x over cos of x. So 1 minus sine squared x over cos of x. Again, once you see a square, you know you're using Pythagorean identities. So 1 minus sine squared x, again, starting with sine squared x plus cos squared x is equal to 1. We know that cos squared x then is equal to 1 minus sine squared x. So we're going to say cos squared x all over cos of x. Okay, use exponent rules. 2 minus 1, we're left with cos of x. So therefore, left side is equal to our right side. Okay, so sometimes we have to expand or factor in order to see that the left side is equal to right side. And this is a perfect example because all the ratios are expressed in terms of sine and cos. So now we have to take it a little bit further. We know sine plus cos theta all to the power 2. That's a binomial square. So we're bringing back our factoring skills and expanding skills. That is factored as a binomial square. So to expand it, we always, so left side, we take sine theta plus cos theta all squared. We square the first. We take sine squared theta. 2 times those two multiply together. So plus 2 sine theta cos theta plus cos squared theta. Now we know sine squared theta plus cosine squared theta is actually equal to 1. So if we took sine plus cos, that's going to equal to 1 plus 2 sine theta cosine theta. So therefore, we've just shown left side is equal to your right side. Okay, so sometimes we have to factor. So sometimes we may need to factor common terms in order to simplify the expression. So when we have something like 1 minus cos squared theta, that's a difference of squares. So again, see how much factoring is important. So I'm going to remind you, that's a difference of squares. Difference of squares. Keep in mind, this is a perfect square. This is also a perfect square. So this would become 1 minus cos theta, 1 plus cosine theta. Here we have a common factor of cos theta. So we factor out cos theta, we're going to have 1 minus cos theta. So they are equivalent. So sometimes we need to factor in order to prove the following identities. Okay, so example 3, have prove the following identity. Use factoring if necessary. Okay, so again, breaking it down, we have left side is equal to cos squared theta over 1 minus sine theta, and the right side is equal to 1 plus sine theta. Now, if you notice cosine squared, the right side is only in terms of sine. So we know cosine squared theta is the same as, if we rearrange a Pythagorean identity, as 1 minus sine squared theta. Now that ends up, the numerator is a difference of squares. So that would be 1 minus sine theta over 1 plus sine theta all over 1 minus sine theta. So again, common factor, those cancel out, and we're left with 1 plus sine theta, which of course is equal to the right side. So therefore, left side is equal to our right side. Right, moving on to B, we have left side is equal to tan theta. Right side is equal to sine theta plus sine squared theta all over cos theta 1 plus sine theta. Okay, so we know left side we can say is sine theta over cosine theta because we want to express all ratios in terms of sine and cos. Now, we need to make sure the right side is going to have sine theta over cosine theta. We look in the numerator, is there a common factor? And in this case, yes, sine theta is a common factor. We're left with 1 plus sine theta. By doing that, by factoring, we then end up with a common factor in the numerator and in the denominator that we can simplify. Those cancel out, and we're left with sine theta over cosine theta. And we've just proven, therefore, left side is equal to my right side. Okay, looking at C. So in this case, because both are in terms of tan, instead of putting in terms of sine and cos, maybe we can try to see if we can simplify further before we do that. So from what it looks like, we can just factor out 1 plus 10. No. So let's take the left side is equal to 1 minus tan squared theta all over 10 theta minus 10 squared theta. The right side is equal to 1 plus 1 over 10 theta. So let's put this all in terms of sine and cos. And there's nothing I thought maybe if we can simplify, you always have to have a game plan. Like don't just rush into it. Think about trying to think what it would be the best strategy in order to prove that the left side is equal to right side. So when we have fractions, so we're going to say 1 minus 10 squared theta, I like to express it as horizontal operation of division. It just makes it easier and less complicated. Okay, right side as well. We'll work with the left because it's more complicated. So this would be the same thing as 1 minus sine squared theta over cos squared theta divided by sine theta over cos theta minus sine squared theta over cos squared theta. Okay, so then we need a common denominator. Be cos squared theta times cos squared theta. Here, the common denominator would be cos theta, just like any other fraction. These just have trigonometric ratios in them, but you do, when you're adding or subtracting fractions, you do need to have that common denominator. So this would become 1 minus, would become cosine squared theta minus sine squared theta all over cosine squared theta. Divided by sine theta cos theta minus sine squared theta all over cosine squared theta. Okay, so in this case then we want to make sure that we can divide them. So we keep the first and we take the reciprocal of the second. So cosine squared theta all over sine theta cos theta minus sine squared theta. Okay, so we see that these will cross out, which is great. And that's a difference of squares. So we then will be left with cosine squared theta minus sine squared theta all over sine theta cos theta minus sine squared theta. So let's try to factor. So that's a difference of squares. So we're going to say cos theta minus sine theta times cos theta plus sine theta all over, common factor there would be sine theta, which is cos theta minus sine theta. Okay, so when we did that, when we fully factored, then we can simplify because there's a common factor there. So the left side is equal to cos theta plus sine theta all over sine theta. Okay, so now we want to work with the right side to make sure that we show that the left side is equal to the right side. Now, looking on the right side, we have 1 plus 1 over sine theta over cosine theta. So basically the reciprocal. So this becomes 1 plus cosine theta over sine theta because you're taking the reciprocal 1 over 10, which again would be cotangent, which is cosine theta over sine theta. Now again, it doesn't quite look like the left side just yet, so we want to make sure we determine that common denominator. In this case would be sine theta. So sine theta, what I do to the denominator, do the numerator. Now we have a common denominator, and this becomes sine theta over sine theta plus cos theta over sine theta. Denominators are the same. So it's sine theta plus cosine theta all over sine theta, which is again is equal to left, because that is the same thing as cos theta plus sine equivalent. So therefore, left side is equal to the right-hand side. Oh, wow. Okay, so looking at example 4, making it a little bit more complicated, we have prove the following identity by finding the common denominator. Right? So it looks a little bit more complicated, but we still follow the same rules. In this case, if we're looking for a common denominator, of course, the lowest common denominator, if you stack, just multiply the two denominators together. So we would say left side is equal to 1 over 1 plus sine theta plus 1 over 1 minus sine theta. The right side is equal to 2 over cosine squared theta. So the more complicated is definitely the left side. So when we look at the left side, we're going to say the lowest common denominator. We're just going to multiply them together. So 1 plus sine theta, 1 minus sine theta. So of course, protect the numerators. This becomes 1 minus sine theta. What I do to the denominator, I must do to the numerator. And then we're going to multiply this 1 plus sine theta. Okay, so that means 1 times 1 minus sine theta plus 1 plus sine theta all over 1 plus sine theta, 1 minus sine theta. So simplifying, we have 1 plus 1, which would be 2. These would negative sign plus sign would just be 0. And of course, we have 1 plus sine theta, 1 minus sine theta, which is the same thing as 2 over 1 minus sine squared theta, because the difference of squares. Now working on the right side, we know using the Pythagorean identities, cosine squared theta is the same thing as 1 minus sine squared theta. So therefore, left side is equal to our right side. And we've proven the identity. Left side is equal to our right side. Okay, last but not least, we have, again, we want to make sure that we are proving the identity by showing the left side is equal to the right side using the common denominator. So looking at B, we have, in this case again, the lowest common denominator happens to be 1 minus sine of x, 1 plus sine of x. Okay, so with that in mind, we're going to say left side is equal to 1 over 1 minus sine of x minus 1 over 1 plus sine of x. So the right side is a little bit more complicated. So 2 tan of x divided by cos of x. Okay, so with that again, protect. I'm going to do the denominator. So it becomes 1 plus sine of x minus 1 minus sine of x. So again, because we're subtracting these two fractions, we just want to make sure that we don't overlook distributing that negative. So this is going to change things. This becomes 1 plus sine of x minus 1 plus sine of x all over. Now, if we wanted to expand that, that would be the same thing as 1 minus sine squared x. And the reason why, notice on the right side, cosine x is in the denominator. So this does become 1 plus, those ones cancel out. So it's 2 sine of x all over cosine squared x. All right, let's see if we can work on the right side. So it's going to be 2 times sine of x cos of x divided by cos of x. Okay, so 2 sine of x cos of x using dividing fractions. It's going to be times 1 over cos of x. And then look at that. So this becomes 2 sine of x times 1 is 2 sine of x. Cos of x times cos of x would be cosine squared x. So therefore, we've just proven left side is equal to your right side.